welcome to this evening's webinar. Really exciting topic, rising to the challenge, why cancer early detection can't wait. Welcome back to those of you who've attended these events before, and I hope you've had a lovely summer. I'm Michelle Mitchell. It's my privilege to be the Chief Executive of Cancer Research UK. And my job this evening is to introduce our fantastic host and speakers. Jane Hill will host the event. She is a BBC journalist and presenter, and also a very, very passionate supporter of a number of charities, including, importantly, Cancer Research UK. Professor Caroline Dive is the Deputy Director of our Manchester Institute and lead of the Cancer Biomarker Centre there. And we also have Professor Rebecca Fitzgerald, who's the co-lead of the Early Detection Programme at our Cambridge Centre, as well as an honorary consultant in gastroenterology at Addenbrooke's Hospital, Cambridge. And finally, and certainly not least, is Dr. Serena Nik-Zainal, also from our Cambridge Centre, where she's an honorary consultant in clinical genetics and a CRUK advanced clinician scientist. So look, a hugely impressive panel. I'm really looking forward to this event, and I'm going to hand over to Jane to get us going.
Michelle, thank you very much indeed. Thank you. A warm welcome to everybody watching, and it's really fantastic that so many people have signed up to see this. So thank you very much indeed. And what a fantastic panel. Just to give you a brief understanding of my involvement with Cancer Research UK, I'm just coming up to the 2nd anniversary of my diagnosis of breast cancer. I found a lump in the summer of 2018, and it took a long time to sort out, and it wasn't until mid-October that I discovered that I had actually a very, very large tumour in my left breast, even though the mammogram had come back as all clear. So it was quite a saga, and it's all gone a bit better since that time, fortunately. But like so many families up and down the country, we are very much affected by this disease. And in fact, in the same week that I was diagnosed, another very close family member was diagnosed with lung cancer and has been having, so far, touch wood, some successful treatment with immunotherapy. So our family, like so many in this country, are very, very grateful for everything that Cancer Research UK does. And so thank you to everybody watching, who many of whom I know are very generous donors to a very, very important charity. So early detection, much to discuss, and I should stress, lots and lots of time for your questions as well. So hopefully you've all got the chat facility and you can type in and send your questions, and that would be absolutely terrific, because I definitely want to get through as many of those as I possibly can as well. Very quick couple of pointers before I chat to the panel about why early detection and early diagnosis is so important. And I don't apologise for just reading from my notes on this, because there's a couple of stats that even I, in my job at the BBC, and as someone who has been very, very interested in health stories for my whole career, there's a couple of nuggets that even I didn't know, that I thought, once you've been diagnosed, you read so much, especially as a journalist, you research so much, you think you know loads about your specific cancer, and there's always things you discover. At its most obvious, of course, catching something before it has spread is absolutely vital. It means it can be treated more successfully. I was very struck when they pointed out to me, also catching it before it's too big means it's treated more successfully. Yes, well, I'll try not to dwell on that, because I'm doing very well for now. For some cancers, survival is more than 3 times higher when it's diagnosed early. And this is the bit I really didn't know, which I found extraordinary. Nearly half of all patients in England are actually diagnosed later, i.e. stage 3 or 4. So 46% of patients in England are diagnosed later, and I had no idea that the percentage was that high, and that to me is really staggering. Symptoms can be vague, that's one of the reasons for that, and it can be difficult to distinguish between healthy and cancerous cells. So that's something I certainly didn't know. Plus, there has been traditionally less funding of early cancer biology, so a lot of the knowledge that we do have is based on the advanced disease. So those are just some of the reasons why there is so much to talk about tonight. The great thing is our 3 panelists are all working in this field and are all working on projects to try to diagnose cancer more quickly, more accurately. So in no particular order, I'm going to ask each of them to just give us a little pen portrait of the key areas they're currently working on, the things that they're excited about. I'm going to start in no particular order based on how I can see them on my screen. I don't know whether it's the same, that everybody has the same layout, but Caroline, that means you go first.
Oh, okay.
Professor Caroline Dive, thank you very much.
Yeah, well, it's an absolute pleasure to be with you this evening to talk about early detection, which all of us on the panel really believe is perhaps the most important thing to do in terms of cancer research for the benefit of patients and individuals. So as well as my role in the CRUK Manchester Institute, I'm also the co-lead of the Lung Cancer Centre of Excellence that's funded by Cancer Research UK. And my expertise is in liquid biopsies. And what I mean by that is the development of blood tests. So we're really passionate to see if we can catch lung cancer early enough for surgery with a really good chance of cure. And the screening that's done in lung cancer at the moment is based on low-dose CT scanning. In Manchester, we do that in the community. And what we want to do is add blood testing to the scanning to see if we can refine the screening to make it more indicative of perhaps those aggressive early cancers rather than perhaps the more benign ones. Now that's biology that we don't yet understand, and we're hoping that really interrogating circulating tumor cells or pieces of DNA shed from early tumors into the blood, if we can analyze those, that'll give us a bit better idea of the biology of that early disease.
Thank you very much. And sitting under you on my screen is Rebecca, Professor Rebecca Fitzgerald. Welcome.
Thank you, Jane, and a great pleasure to be here to talk about early detection of cancer, which I've spent my whole career focusing on because I think it's so vital to really improve outcomes for patients. And I'm a gastroenterologist, and my particular focus is on cancer of the esophagus. And that's perhaps a cancer we don't hear so much about. It's not uncommon, it's not rare, but it's not one of the commonest. But it's increased actually 6-fold in the UK in the last 30 years. And the 5-year survival is 13%. So, you know, speaking to some of those statistics you mentioned, it's a really dismal cancer. And I've been looking at new innovative ways of trying to diagnose it early, which don't rely on endoscopy, which is the current gold standard. And so we've been developing and trialing a new test called Cytosponge TFF3, which is a very simple test that you can do in the GP surgery that just involves swallowing a pill on a string. I'm sometimes nicknamed the sponge lady, I think. Swallow a pill on the string, let it dissolve, pull out the sponge and do a test in the lab. So incredibly simple. Scientists often like to boast about the complicated, sophisticated things they do. This is very simple, but we designed it to be very simple to pick up this cancer really early. And we've been doing some exciting trials to see how that performs. So that's what I'm excited about at the moment in this field.
That's fascinating. I'm sure your patients are far more flattering about you than calling you the sponge lady, but we know where that comes from, so we'll move on. And I'm hoping, I'll come back to you on some of that because it's really interesting. And I'm hoping that Serena Nik-Zainal can give us her own pen portrait as well. I can't see Serena right now, and I could earlier, but Serena, I hope you're there and can tell us more.
Yes, I am. Thank you very much, Jane, and thank you so much for the opportunity to come onto this panel. I feel really honored to be here to be able to talk about my research. So I'm a CRUK advanced imaging scientist. I'm based at Cambridge. Medically, I'm a clinical geneticist. So I diagnose and manage families that have genetic or inherited diseases of any sort, ranging from learning disabilities through to families that have inherited cancers running through the family. And I got into cancer research because the technology to read the genome became available. The speed and scale of sequencing of reading the genome increased phenomenally in sort of the early 2000s, and I came into research about 2009. And my team, scientifically, my team reads cancer genomes. We read the DNA of human tumors. And the purpose of that is to be able to understand why a cancer has turned into a cancer, why this person's tumor has become a tumor. And as the cancer develops, it leaves all these imprints, all these patterns. And if you study those mutations, you study those patterns, you get a sense of why that person's developed a cancer. So it's all about improving the accuracy of interpreting cancer genomes.
Wow. All right. Thank you very much. I'm already going to have to find another word for fascinating over the course of the evening, because I'm so interested in all of this. It's everything you're working on is so impressive to mere journalists like me. Let's just talk just a wee bit more about some of the specializations and the things you're working on that you've outlined there. And Rebecca, I mean, I'm really glad you said that the esophageal cancer is perhaps sort of less known, less talked about, because when I read that you were a specialist in that, I thought, oh, I'm so ignorant. I don't know anything about it. So I'm kind of quite struck that it is one of the not a hidden one, but a less well-known one and a less talked about one. So talk a wee bit more, could you, about what you started describing, that method of working without an endoscopy, and is one of the benefits of not using an endoscopy just that it's a very unpleasant procedure, or is it a bigger picture than that?
Yes, so endoscopy is pretty straightforward, but still you have to be referred by your GP for an endoscopy, and that's it is unpleasant. It's uncomfortable. It's not, you know, it's not the end of the world, but you're gonna have to take a day off work. You'll have to go to the hospital, and it's quite an expensive procedure. And if I tell you that the main risk factor for this cancer is persistent heartburn.
Wow.
Now, you know, immediately we can start to see the scale of the problem, and that gets to the nugget of some of the issues with early detection, because there's a very, very common symptom that most of the time is simply a nuisance and it isn't going to do you any major harm at all. But in some people, it can lead over time to chronic inflammation and to developing a precursor called Barrett's esophagus, and that may then, in a small proportion of people, progress to cancer. So it's a very common symptom. That can be important, but probably won't be. But we need to know who those people are at risk. So do you endoscope everybody with heartburn? Can you imagine?
Yeah.
It's not going to happen. And so we need to find a way of getting to the people at greatest risk. And so that's why we've really focused on something which is so easy to do, that instead of referring out for an endoscopy, the GP could take their patients having repeat medication for heartburn, who they think are at risk, you know, could be at risk, and do a very simple test and work out who needs an endoscopy and who doesn't.
And the fact that symptom is so common, I mean, heartburn could be so many other things. Is that presumably, I mean, I'm trying to put it into very much lay terms here, but is that presumably a reason why it can be diagnosed so late?
And so the symptoms, you know, the esophagus is a muscle, it's a stretchy tube. So you can start to have a lump that's growing there, and you will still be able to swallow your food no problem until that lump really gets quite large. So the symptom for the cancer is difficulty swallowing and weight loss. And that's how most of our patients present. And at that point, they've usually got an advanced, and to give it the technical stage term, stage 3 cancer. That's the vast majority of our patients present with stage 3 or stage 4 disease. You mentioned a statistic earlier about, you know, around 50%, and it's certainly around 50 to 60% of our patients that will present then. And so we want to get them before they've got those symptoms.
Yes,
when it's really early, when it's pre-cancer, when it's Barrett's. And so that's why the heartburn is then, you know, gives us some idea, but most of the people with heartburn won't be at risk, but a proportion will be. There are other risk factors too. If you're male rather than female, that puts you at a high risk. If you're overweight, so there are other things you can add on to start working out who you should test. But you need something simple, because before you get your swallowing difficulty, it's going to be difficult to know that you're at risk without having a look.
Yes. Okay. Thank you. Might come back to all of that, but Caroline, I'd like to hear from everyone. Of course, Caroline, you talked about detecting circulating tumour cells. Talk a wee bit more about that, if you can, and why that's such an exciting area of research.
Yes, and normally when we think about the development of cancer, we think about the development of cancer metastases, which are mostly generated by cells which break away from the initial tumour, get into the bloodstream, move around the body, and find somewhere else to lodge and grow. And it's in sort of historical terms, that's been thought of as quite a late event. But what we've found out with lung cancer quite recently is even in early stage 1 cancers, you can find circulating tumour cells. So some cells break away and get into the bloodstream early. Ergo, they can be an early detection test. but you need really sophisticated technology to find them. So they're very, very rare cells in the blood. But if we can find them, if we can capture them, if we can isolate them, and with the help of folks like Serena, if we can sequence them, you know, we can learn an awful lot about that early biology of that tumor. Now, it may be, and one of the studies we did recently was that we did exactly that with some of these early cells in the bloodstream. And it turned out that 10 months later, they were the cells that had caused a metastasis. So, you know, they are out and about early. Some of them are really dangerous, not all of them. And it's really understanding cell by cell how that early biology might look. We don't just measure the circulating tumor cells, we measure the nucleic acids, the DNA, we also measure the proteins that the tumor cells may shed into the bloodstream. And what we really want to do, as I said earlier, is, you know, we can now use, and I think with lung cancer, it's a bit different from esophageal cancer. There is one very big risk factor, which is smoking. So smoking prevention, obviously, really good idea too. But I want to be able to reach out to those folks who live in those socially deprived areas where lung cancer is much more prevalent, North Manchester being a very good example. And those folks don't generally turn up to see their doctor until it's way too late. So they're not the intelligent, worried well, they just don't turn up in time. And so what we're trying to do is get our screening for early detection of lung cancer in the community where these folks live. So they can come to their local supermarket, they can park, point number one, always difficult at hospitals. They can go do their shopping, they can jump into a van that has a CT low dose scanner, they can have their thorax scan, takes about a quarter of an hour at most, but they can also give us a blood sample. And we can now interrogate that blood sample and see whether the molecules that relate to perhaps a cancer map to the scan that they've had of their lungs. Now, sometimes those scans look a bit odd and we're not really sure whether that's a cancer or not. But if we had, for example, one of Serena's genomes from a circulating tumor cell, as well as a scan that looks a bit odd, you'd have a lot more confidence that that patient then should be referred, have a thorough diagnosis, maybe find that early tumor, have surgery, great chance of cure. And taking that one step further, as we get better at this blood testing, can we even pick it up before the scan? And we can come back to the pros and cons and how difficult that might be. But that, in a nutshell, is what we're really trying to do. But I want to reach those folks that need us the most, who are, you know, the not so well educated, not so wealthy, and the folks who are most likely to be getting cancer because they have bad lifestyle habits.
I mean, and that is really interesting. I am going to come to Serena in just a sec, but the whole idea of just literally setting it up in a car park and encouraging people and allowing people, I mean, that presumably as well breaks down barriers. I mean, awful stereotype about men, particularly older men, not going to the GP, but actually, is there a reason that stereotype is there and that it works and that someone might be more likely to venture the thing you're talking about?
I think that's true. You know, well, my institute suffered a rather bad fire a few years back when we first started thinking about this way of doing early detection for lung. So I had no lab for a while. So I went actually and spent a couple of weeks in the vans, in the car parks, participated with helping the folks come in, did a bit of a questionnaire with them, sat with a nurse who consented them for their scan and their blood test, and actually chatted with these folks. And I learned a huge amount. You know, they try and give up smoking. Sometimes they're successful, sometimes they're not. But, you know, they actually were very, very happy to give their blood sample for research. You know, they're salt of the earth, you know, and we need to do the best we can to make sure we catch their tumours early.
All right. Well, yes, and we are definitely, I can see there are already questions coming in about the sort of risks and benefits of all of this. But as I promised, Serena, let me bring you in terms of now you're focusing on computational modelling using genetic information from patients. Now, I have to confess, again, an area I knew very, very little about, but people far better informed than me tell me that this is something that's really growing. There's a lot more that's perhaps this has taken off in the last 10 years or so. So explain a little more about that, why it's so exciting and what the possibilities are there.
Sure thing. So all the cells in our bodies, they carry DNA, right? It's our genetic blueprint. And it turns out that the DNA in cancers are highly disorganized. It's very, very different to the original DNA that each of us had when we were first conceived. So it's mutated, it's evolved away from its sort of starting normal, pristine state. Now, those mutations, they arise as a consequence of the cell turning from being a normal cell into a cancer cell. So they document why something has turned into a cancer. So a cancer genome is like an archaeological record, if you will. It's got all the causes of each person's cancer almost fossilized into the DNA. So if we could read the cancer genome, if we could understand that archaeological record, that would be really useful. So my team, we read cancer genomes. We basically look at all the DNA building blocks in every cancer, and we try to document we try to report every single mutation. And mutations also leave patterns, so we try to report on all of those patterns. But we have to remember the human genome is enormous. Yeah. It's too big to read easily. And that's why we need the computational methods. We need to speed up the process, so we use computers to help us read the genome quickly. And we use the computational methods to interpret the cancer genome. So it's not just about reading them, we have to read it and also interpret it. It's like reading a book. You want to try to get the gist of what is wrong with your cancer. So we aim to figure out which mutations or patterns of mutations could be targets for specific therapies. So there are some mutations, there are some patterns that could be a sign that a tumor is sensitive to specific drugs. And it's also a way of us to try to see whether there are signposts for a tumor being more malignant or more aggressive, if you will. In terms of early cancer detection, the ideal place that we're aiming for is to be able to use mutations or mutation patterns as early as possible in the patient's diagnostic journey, but not just to say that you've got a tumor. What we want to do is be able to distinguish the tumors that are going to be life-limiting and aggressive from those that may be a bit more indolent. So, I suspect there are going to be some questions about the risks and the benefits, and this sort of touches on what Caroline was just saying previously. It's if you can detect an aggressive tumor early, that's really quite an important piece of information.
Okay. I've tried to get my head around the sheer scale of what you're doing there, and it seems to me you could employ, I don't know how many people are in your department, I don't know, you could probably employ thousands and thousands and thousands, and there'd still be more work to do. I mean, the scale of it is absolutely mind-boggling. I think if I can just bring in a couple of questions because there's quite a lot already, actually, and I'm terrified of missing people out and forgetting people. It ties in with some of what you've all been saying. A question from Andy, who says one of the challenges of early detection is that you have to ideally have a very low level of false negatives, but also a low level of false positives. Could you talk through that challenge and why in particular false positives are so undesirable? Rebecca, would you like to come on to that one first? Thank you. The question.
Yeah, I'm happy to talk about that. So I think that's a really important question and something we absolutely grapple with in this field. And I think one of the key things is what the consequence of that false positive might be. So if I could talk through some different scenarios that we see for patients presenting with a possible, I'm going to take stomach cancer. So, the consequence might be if you had a test, your GP surgery, or one of the blood tests that Caroline was talking about, for example, or swab or something, and someone said you might have stomach cancer. If we said, well, then you need to come for an endoscopy, and then at the endoscopy we said, well, good news, actually it's all fine, you don't have stomach cancer. And okay, you've had the inconvenience of an endoscopy, and you probably, from the patient's point of view, wouldn't feel that was so bad. On the other hand, if you had an endoscopy and we saw a tiny little thing and we said, we're not quite sure what it was, but we want to remove it, but it's okay, I can do that. If you come back next week, I can do it as an outpatient procedure. It's just going to take half an hour. It's not a big deal. And you probably still think, that's okay, I want to know what that pimple is, and we take it off. And we might then say, actually, it was nothing. And you probably still think that was fine. But if you came in and said, well, we're really worried about this, we think it could be quite a serious cancer, it's quite difficult for us to tell, and what we would recommend is we remove your stomach.
Wow.
Then you're thinking, wow, this is big deal, big stakes, right? And if we remove the stomach, if we find that we've just caught it in time and we've saved you from having something horrific, then it's okay. But if actually we say we didn't find anything, or, when we've removed a whole series of these stomachs, we find that actually it was important four times out of 10, but not 6 times out of 10, then you'd probably be thinking, hang on a minute, this is absolutely not acceptable. Now, that sounds completely far-fetched, but for example, we have patients with Serena was talking about genes that make you more susceptible to cancer. So we have patients we look after with a hereditary form of stomach cancer, but we still can't tell for sure whether that individual is going to get a stomach cancer. But the risk is so high that they have prophylactic surgery. But it still may be they'll be one of the lucky ones who never ended up getting a stomach cancer. We just don't know when we do that operation. So that's an extreme example, but I think perhaps it then focuses the mind on, you know, on this false positive business. And I think then, you know, so it is partly about what you're going to do about that information, what that means for you, how that's going to alter your worry state and, you know, the consequences for you. And then, of course, from the health service point of view, if you start chucking up a lot of these false positives and you're having to pay for a lot of procedures, then, of course, that also has big implications. So it's very, very important. And all of us in our thinking and you know, working on these tests want to find that sweet spot where we don't miss cases, but we're not over-diagnosing and over-treating. So absolutely paramount, and I'm sure for all of us in the tests and the work that we're doing, it's, you know, very much at the forefront of our minds.
Oh, I mean, yeah, and you're talking about major life-changing. I mean, that it's remarkable what you're working on, but it's a Herculean task. It seems to me, as a layperson, as I always like to say, as a classic arts graduate, it's not a science graduate. That's what I like to remind people. Serena, I'll bring you in a moment because I know some of this ties in with your work around DCIS and that particular form of breast cancer, which is really interesting. I'm just going to see, we do have someone who'd like to come in and ask a question. Jeffrey Silkstone, I think you have your hand up. So fingers crossed, I'm hoping someone can work some technical magic and we can actually hear from you.
Jeffrey's on mute at the moment.
Ah, is he? Jeffrey, maybe you can unmute yourself.
Can you hear? Yeah, can you hear me okay?
We can
Hello?
now. Go ahead. Ask your question to the panelists.
Okay, yeah, I'm sorry. Yeah, my question is, it's with the benefit of hindsight, I realized after my partner's death from liver cancer that she was showing symptoms of the cancer well before she was diagnosed by Adam Brooks in 2016. I wonder whether someone could tell me, why do you think this was? The other question to go with that is that I did actually at the time tell her, both herself and her family, that she was showing odd symptoms, but I didn't realize that it was cancer. And unfortunately, no one seemed to take me seriously. So the conclusion really is, whether you can or cannot answer my question, it is quite clear that we really need to get early detection through to people in order to bring about these breakthroughs.
Jeffrey, thank you very much, and I'm so sorry your family has been so badly affected. You've obviously had...
No, it's okay. I mean, I'm just trying to be pragmatic about the whole thing, and I just wondered why it took Adam Brooks so long to diagnose the cancer, because she'd had liver cirrhosis and she'd been having regular checks for some years. So it just seemed strange to me that it did take so long to detect the cancer. But I'm not blaming anybody, because I realize that this is a difficult field, and you know, we have to sort of take that along as we go.
Oh, absolutely. Is it either Rebecca or Caroline who might want to pick up on that? Is that one for you, Rebecca?
Yes, I mean, so sorry to hear that, and you're right, there's so much more we need to do, and I think it's on several different fronts that we need to tackle this. One is around the awareness of patients and the public when they start noticing things, you know, to come forward. Obviously that wasn't an issue in your case, but that's an issue. And then it's educating our GPs about when to refer for tests, and then it's having the really good tests. And you know, when we're looking at people with cirrhosis, as in this case, with scanning and so on, we don't always get it right. Some of our tests aren't good enough to really work out.
Yeah, no, I do realize that. Yeah. Yes.
And so that's exactly why we need more research in these areas so that we can get it right more of the time.
Yeah, yeah.
So thank you for the story.
Pardon?
Thank you so much for sharing that story with
Yeah, no, as I say, it was something I needed to sort of just get out, because it had obviously, you know, I mean, I blame myself in a way after she died, and I sort of felt guilty that I hadn't made probably enough noises about the problem that I could see, whereas other people couldn't see the same problem, you know. So it does sometimes sort of convey an element of guilt on the surviving partner that maybe you haven't done enough, you know.
I understand, and we all feel that to some degree, and as doctors we feel that too, you know.
Yeah, yeah, yeah. Okay. Well, thank you very much for your time. Thank you.
Jeffrey, thank you so much. Thank you for your question. All the very best to you and your family. Thank you very much. Lots of questions coming in. So I think, Caroline, this next one might be for you. A question from Danny, who asks, can you analyze what a circulating cancer cell is doing to stop it circulating and therefore possibly causing a different cancer somewhere else in the body, which sounds like a mini disaster? Are you the best person to unravel that?
Yes, and this is the sort of research that we are making some good progress with, but it's technically hard. Single cell analysis is always hard, and this is, if we do enough of it, I'm hoping that Serena and folks like her will see patterns in the genomes of these circulating cells that will give us clues about their level of dangerousness, if that's a word. Are these the ones that might go to the brain and cause havoc? Are these the ones that might go to the liver and cause havoc? So, are they aggressive? Are they just going to die in the bloodstream? So are they going to cause no trouble at all? And these are some of the things we need to understand. And what we now know is circulating tumor cells sometimes don't travel by themselves. They travel in little mini gangs. So then the question is, who are they traveling with? Which cells are they traveling with? Are those cells keeping the tumor cells alive in the bloodstream and helping them get where they go next? So all of this biology of what's going on in the bloodstream, we need to know more about. And, to do that, obviously, we need to have funding and do more research. But it's absolutely fascinating. You'd be surprised what some very aggressive lung cancer cells can do. They can even make their own blood vessels, a process called vasculogenic mimicry. So that allows cells to escape into the bloodstream because they're making the vessels. The vessels allow the blood into the tumor and give it more oxygen, allow it to grow. So there's all of this biology, which we thought was late tumor biology, which actually is probably happening quite early. So again, by studying the blood, and actually what we really need is some better preclinical models of early biology to study this more. So, these are big multidisciplinary teams that we need. We need funding for a long sustained period to make the strides and discover the knowledge so that I can answer that really good question much better than I can at the moment.
And I mean, again, Caroline, from everything you're saying, I'm extrapolating, but I'm assuming this, if a big cash cow came along and, gave you a load of money, I mean, what you're talking about, because of the scale of it, like what Serena was saying about scale, the scale of it must mean that it is extraordinarily expensive, I'm assuming.
Sure. Right now it's pretty pricey, yes. You hope as technologies develop, and they constantly do, the prices will come down over time. But it's not just the technologies that are expensive, it's the size of the experiment that you need to do in early detection. So, when you think about it, in our scanning lung cancer trial in Manchester a couple of years ago, we had a 3% positive CT scan positive rate in our population, which was high because it was the population that was at high risk for getting lung cancer. And of those 3%, half of them turned out to have an early cancer that could have surgery, and half of them were false positives. So, we have to improve on that, and that's what I'm hoping the blood test will do. But we need thousands of individuals in these trials so that statistically we think we can get it right. We've got the chance with a really large experiment to be sure. And we come back to this false negative, false positive argument. And what I'm hoping is if you can have a blood test, you can have it often. If we only need 10 mils of blood, 2 tablespoons, And you could have that blood taken in your local pharmacy. You know, again, go and do your shopping, pop into your pharmacy, give some blood. It comes back to the lab. We have a really good look at it. I can't do that now, but I'm hoping down the line that's what we'll be able to do. If you have you know, a very small number of molecules that you're looking for, which is your signature of an aggressive tumor, and there's a threshold above which you're going to make the call, yes, this looks like an aggressive tumor, and below which you're going to say, no, that's nothing, and you want to be right, you've got to do that experiment a lot of times. And you know, you've got to be sure, because otherwise we run into the problems. You know, in lung cancer, the last thing you want is to have surgery for a diagnosis of a lung cancer when you haven't got one. And you certainly don't want to be worried that you've got a lung cancer, because for the most part they're incurable, although as we all know, the treatment of later lung cancer is getting better. But there's an awful lot of lung cancers that don't respond to treatment when they're caught late. So again, the expense is not just in the technology and the cost of doing that experiment on that one patient. The cost is the size of the experiment you need to do to power that experiment to make sure you get the right answers. So big experiments, big expensive experiments.
Yes. Okay. I can see quite a few questions coming in about lung cancer. I do, before I go to those, Serena, I'd like to come back to you, because we were talking about some of the disadvantages perhaps to early detection. And I know you're working on something around in connection with DCIS, which I'm obviously very interested in. And you're working on a grand challenge around that, around DCIS. Explain a little bit more about that.
Sure. So DCIS, for everyone else, is ductal carcinoma in situ. It is a potential precursor to breast cancer, not for all breast cancers, but for some. It's believed to be one of the earliest steps towards developing cancer. But it's a classic example of an early detection challenge, because we're diagnosing a lot more cases of DCIS through breast cancer screening programs, but it's not clear whether all of those DCIS lesions that we've identified will necessarily turn into life-limiting cancer. In other words, some DCIS tumors may simply stay indolent and will never be malignant and never pose a threat to the person who was diagnosed with it. So, sort of echoing what Caroline was saying, we create these screening programs to identify cancer early, but we have to also consider the possibility that we are identifying too many people too early and potentially cause them harm if we treat them like cancer patients for cancers they were never going to have. So some people may say, okay, if there is any risk of cancer at all, I just want it minimized. Please just remove my breast, remove the lesion. But others will say, well, I'm going to put myself through a surgical procedure, sometimes relatively big, and have all the attendant sort of consequences from that surgical procedure. And some people have a lifelong case of swollen arm, it's called lymphedema, and they can sort of identify with being a sick person, a patient, for a long time. So there are other sequelae, potentially for no reason at all. So the real challenge, I think, for early detection is to be able to distinguish those tumors that are really life-limiting, that are really aggressive, from those that aren't. And in our grand challenge, this is a jointly funded exercise by several cancer charities. So it's CRUK as well as the cancer charity in Holland called KWF. This grand challenge was a really big grant that's united research teams studying DCIS in multiple different countries. So it's the US, UK, and Holland. All of us doing DCIS research together, pooling all the data together, putting all the patient samples together to be able to get that size, that scale of patients that Caroline was talking about. You need many, many patients in order to be able to say whether you think something is robust or not. And the idea is to try to find distinguishing features that can tell you whether a DCIS tumor is going to turn into cancer or not.
So very briefly, just today in the UK in 2020, if a woman is diagnosed with a DCIS, are we still in the world where she just has to have treatment, perhaps she probably has to have an operation, unless she chooses not to, but chances are we still at the point where we err on the side of caution, because that's as much as we know?
So currently in the UK, and actually even in Holland and in the US, they're starting to do trials to explore this and to explore whether someone will actually be happy to watch and wait. And so when you have a tumor diagnosed, they do staging. They try to figure out the size of the tumor, and they look at the cells to see whether the tumor is more differentiated or not. So is it a more mature looking tumor or not? And and they sort of weigh up all the information together, and then they discuss it with the patient, and they sort of say, look, we're not 100% sure whether this is something that needs to be removed or not. And I think the range of options, I cannot say this happens in every hospital, but I think in certain places, there are a range of options which include everything from sort of a surgical procedure to remove it, through to watching and waiting and having sort of more regular screening for the lesion. So I think we're starting to explore, whether people are prepared to watch and wait. But I don't think the results are out yet. So that's one to watch.
Okay, one to watch. Excellent. Simon Ayers is a supporter of the charity who I think would like to come on and talk a little bit about his thoughts or his experience in terms of early detection. Simon, are you with us?
Thank you very much for letting me speak. I mean, I'm a lucky one, and I'll just quickly talk through my story and why I support CRUK and cancer research. I mean, my story is probably more common than most men would care to admit. I was 53, successful career, and for years I ignored my symptoms. I was lucky. I had a GP who bugged me for months and months and months and years, and eventually persuaded me to follow up with a biopsy. And of course, my prostate was riddled with cancer. I was operated on by a robot. It took 3 hours, but a couple of weeks later, I was back at work. And for me, that's kind of the story. But I think what I didn't realize at the time, what most people don't realize, is quite how common cancer can be. I mean, prostate cancer, breast cancer. What most people don't realize is that half the UK population will get cancer of one kind or another. So half the people on this call will at some time in their lives get cancer. If you're with somebody, one out of the two of you is likely to get cancer. Cancer is just an incredibly normal thing. We're very likely to get it. But the good news here is that just as it's normal to get the disease, it's also increasingly normal to survive it. And I don't think of myself as a survivor. I mean, I think of myself as a normal person. It hasn't marked me in any way. But I was lucky. I had an easy form of cancer, and it was diagnosed in time, not early, but in time. So having done a bit of research, cancer was first written about by the Egyptians in about 1600 BC. But it's only since the 1970s that outcomes have changed. So nothing changed for 3,500 years. And then over the last 40 years, survival rates have rocketed, which is obviously fantastic. And the more common cancers like breast cancer and prostate cancer more than the others. Across cancers, though, early diagnosis is critical, and that's why my wife and I support CRUK in its research. The stats are that if you diagnose cancer at stage 1, something like 90% of people survive. And if you do it at stage 4, it's less than 10, and the people on the screen know more about it than I do, but those are the numbers that I have. So early detecting people at stage 1 makes multiple difference to survival rates. And the easier the tool, the better the tools, the easier they are to deploy. That test in a car park deals with people like me who are too busy, don't really think it's going to hit them. I think it's a mix of being too busy and just having no idea that there's a 50% chance that I was going to get cancer at some point in my life. That persuaded me in the end. So from our part, my wife and I, coincidentally, we contributed to the CRUK as it was being built. But we now support a 3-year, we've provided a 3-year commitment to CRUK's Cambridge Early Detection Programme. And we love the way that brings together a team of multidisciplinary scientists, I mean, cancer cell biologists, sociologists, statisticians, engineers, physicists, a load of people working together in a cross-disciplinary fashion to better understand the disease and come in through different entry points in a way of finding ways to build tools to detect it sooner. And just to finish, I mean, to me, it's just so obvious that we should be supporting cancer research. I mean, we brush our teeth so we don't get gum disease, we put on a seatbelt in case we crash our car, we buy house insurance in case it burns down. But none of those things is as likely to happen to us as getting cancer. But so few of us support cancer research. So please, people on the call, join me in supporting the team here. Thank you.
Oh, Simon, thank you very much. Thank you, and very glad that you are fighting fit, and wonderful that you've contributed, been able to contribute as much as you have. Yes, all the best to you and the family. Thank you very much indeed. Thank you. I do, before I can see still so many questions, and I want to just try and nod to the future a little bit before we run out of our hour. A couple of more promising things as well in these difficult times. Let's try to think about some promising things. Rebecca, I know you're the co-lead of ACE, which I'm afraid, again, I didn't know a huge amount about, but can you explain a little bit more about that?
Yes, ACE, a great name. We want to ace it. This is the Alliance for Cancer Early Detection. It's an international alliance, and Simon just spoke to the Cambridge programme, which is an interdisciplinary programme for early detection of cancer. And we think the bringing together of disciplines is so important. And this international alliance takes that one step further. So the alliance involves 5 centres: Cambridge, Manchester, UCL, and then in the US, the Canary Centre at Stanford, and the Oregon Health Sciences University program. And all of those universities have committed to have a major effort in early detection. And this is a hard research challenge. This is a tough one to crack, right? And so the idea is if you bring people together from different institutions with different expertise across different disciplines, we can really spark off each other, come up with new project ideas, build capacity in the field, have exciting exchange programs for our students getting into the field, and have access to cohorts as well across our different centres, so that we can do these big studies that Caroline was talking about earlier, that you really need a lot of patients followed for a long time. So this is an exciting new initiative of CRUK's that's already showing some dividends. We've got some exciting new projects across the Alliance. And yeah, we're just at the beginning of this alliance, so I think much more to come.
And I mean, I'm always so interested in best practice and what we can learn from other countries, when there are things we can learn from other countries, whatever the journalistic story I'm working on, but there's always things we can learn. I wonder whether, because I spotted one of the many questions that's come in was asking about whether this ties in, Rebecca, with what you're working on, because it says, John asks, why are cancer survival rates lower in the UK than in many continental countries? Are these countries just better at detecting cancer earlier? And if so, what can we learn from them? I don't know whether there might be other panelists who'd like to nod to that as well, but Rebecca, are other countries doing it better than us?
Well, they certainly have better outcomes, absolutely correct, and it makes rather sobering reading when you see it plotted out across the countries, across Europe and worldwide, yeah, I'm afraid we don't do so well in the UK, and I think, you know, it's not one simple reason, unfortunately, otherwise we could fix that in a stroke probably. But it's probably a combination of maybe our British reticence to go and see the doctor. We just heard a bit about that. I think I resonate with that too. So I think there's some of that. We have a fantastic National Health Service, but at times it's overstretched. And some countries, they have different models, direct access and so on, more onus on the patient. They're more willing to go forward and get tests directly. And then we have some bottlenecks in our service. So I think there are probably several reasons, but I think we have to absolutely learn from best practice and you know, work out how we can do better.
And I'm struck by how many of our questioners have made reference in various points tonight to people's unwillingness or not wanting to bother the doctor. It's interesting that you, even in your role, you see that or feel that. Are there, Caroline or Serena, did you want to add to that at all before I move on to another question in terms of best practice? And
no, I think, you know, completely agree about, I mean, we're also, as part of the ACE, you know, it's very exciting to set up these international collaborations and to learn, you know, from other centers, in this case in America. So I think, you know, it will all come down to multidisciplinary teamwork, learning those best practices from wherever we can.
And Serena, you were awarded an Advanced Clinician Scientist Fellowship. Can you explain for people watching what exactly that means and how it benefits you and your work and all the research that you're able to do?
The fellowship grant from CRUK provides me with a salary, actually, to cover me to do research. It allows me to not do any NHS service work. I can do some service work, not too much, but it sort of releases me from NHS duties so that I can focus on research. It also gives me expenses to start my team, to hire new talent, to attract and recruit new people, to pay for running a lab, and to do experiments. So a fellowship grant is, for me, it was absolutely essential to be able to develop a scientific team so that I could explore cancer genomics ideas in huge depth. You know, you can have research ideas, that's wonderful, but you need the funds to be able to implement some of those ideas and to test them out. So a fellowship grant's like an injection of capital, as it were, into a business, getting it off the ground. But you know, I can say that when you fund a scientist, a clinician scientist, you are investing in the intellectual development, into the maturation of his or her scientific ideas. And you could actually see a return in those investments relatively quickly. So I was reflecting on sort of, you know, I only started research in the UK in 2009. And at that point, we were just starting to read cancer genomes. It was extremely difficult and extremely slow. And today, in just over a decade, we've been able to develop some really cool computational tools. We've gotten patents. We've applied these tools into populations in Sweden, in the UK through the 100,000 Genomes Project. 15,000 human cancers have seen our tools applied on them. We started to hit clinical trials. All that in less than a decade, and the vast majority of that was as a CRUK fellow. So it just couldn't have been done without a CRUK fellowship. I think the other thing to say is a fellowship is an opportunity. A fellowship from a charity like CRUK, it's an opportunity for someone like me. Okay, so I'm a foreigner here. I've made the UK my home. I've come and I've settled here because the opportunities provided by these fellowships exist here. So you know, that's how important the fellowship was to me, and how it's sort of supporting my team and our ideas to kind of grow and develop further.
I mean, obviously, I'm very interested in from all three of you in your sort of, there's a big question, but here we go. Classic journalist question at the end of an interview to say, what are your big hopes for the future? But you've touched so much on the scale of all your projects, the work that's being done, international cooperation. I mean, there's a lot to be positive and excited about, but equally, well, to Simon's point, half of us certainly in this country are going to get something in our lifetime. And in these, you know, desperately difficult COVID times, and I did not want to get bogged down in coronavirus because we've all had enough of that, but is that even more of a challenge for you? How do you stay positive, I suppose, and what are the key things that you're looking at and thinking about in terms of really working so hard on early detection? I'm sorry, I appreciate that's a huge question, but Caroline, can I come to you for some sort of final thoughts on your optimism or otherwise about where your work is going?
So I guess one of the very few advantages of getting older is, you know, I've been working with CRUK for decades now, and you know, I'm just so thrilled that CRUK are now channeling quite a lot of funding to this early detection problem. Rebecca may remember days of the biomarker committee that I used to chair for CRUK, and we hardly ever saw any early detection grants. We saw the earliest grant I think Rebecca wrote, and we funded it, which I'm very pleased about, because look how well that's turned out. But now, you know, we have whole programs, we have the International Alliance, we have the Grand Challenges. So I'm actually very optimistic, actually, that, you know, we'll get through this pandemic, and we shouldn't forget people are still getting cancer. You know, we need to focus our efforts. We need to have funds coming in for this continuous and significant support and this focus that CRUK are putting on early detection. And it's clear why. If we can get this right, we can really help humans. You know, so the health of the public will be transformed if we can get early detection of cancer right. So I am optimistic. I think technology, as Serena has said, is moving forward at such a pace. We shouldn't underestimate the challenge. We should keep our foot on the accelerator. But yes, I am very optimistic.
That's wonderful. And in fact, one of our questioners would like more of a date. I don't blame him. He should be a journalist. Again, that's the sort of thing we do. Presumably, he says, when we can successfully use our immune system to detect cancer cells, we'll be well on the road to early detection. So when does your research suggest this might materialize?
Right. Well, does anybody else want that one? I'll take it.
Exactly.
That's a hard question. Yeah, we'll see how I get on as a not immunologist.
Yeah, we can hold you to
but it's a very, very good question. And only this week I was on a Zoom call with Professor Lisa Cousins at the OHSU, part of our International Alliance for Early Detection, exactly talking about that question. So the screen detected lung cancers that are resected, those tumors that come out of the patient, we can now look at for the first time. We hardly ever used to get them because they weren't detected early. But now that we are beginning to detect lung cancer earlier, we can look at the immune landscape of that early disease. And we can begin to figure out, what is it that we could target? What is it that the immune system sees early? Because you're quite right, questioner. Presumably the first thing that happens when a tumor starts to develop, and Serena might want to comment, and those mutations are being passed down cell by cell, is the immune system at the beginning might say, hang on, something's going on here. And then the inflammation starts and the immune system says, something's definitely going on here. And we need to understand that. And if by getting to the point where the lung cancer screening with the imaging finds the tumors, the patient has a resection, and we can look at that immune landscape with immunology experts, which we have plenty of in the UK. I just happen to be talking to one over in Oregon as part of our International Alliance. These are the experiments that we now need to do.
And Serena, did you want to come in on that? I saw you nodding through some of that.
Yeah, no, I totally echo the sentiments that Caroline was making there. So, I don't think I have too much to add there. But yes, I think we're still at the early stages of trying to understand that interaction between how a cell is changing. As I mentioned earlier, the cells are changing from being normal to being a tumor cell. How those changes result in the interaction with the immune system. And then how actually sometimes the tumor manages to shut down the immune system, it evades the immune system and survives. And there are some drugs out there already today which aim to revitalize or sort of reawaken we call it antigenicity, so the ability of the immune system to see those tumor cells and attack them again. So today there are some of those drugs available, but we don't necessarily fully understand how some of those drugs work. But so we're early stages, very optimistic. Those are the early drugs. I'm sure there's more understanding and more therapeutic interventions to come.
We all hope you're right. Mary Beth, I'm doing one last shout out because I don't want her to think that I'm being rude if she is definitely trying to get through. Wonder whether she is there. I think I'm going to take that as a no, sadly, because we are creeping towards the end of our hour. And Rebecca, I would, of course, as well like to come back to you for some closing thoughts about your.
Yeah, it was just a last reflection on, what's the promise of the future, and just one word of optimism, I guess. I mean, COVID-19, such a difficult situation we're in, and cancer, has got real challenges just there. But actually, there are some silver linings as well, because we are realizing that we need to embrace innovation. And typically, drugs we know take a long time to develop, and diagnostics also take a very long time from the point at which you've got something to actually implementing it. But one silver lining of this pandemic has been to look at some of the diagnostic tests coming through and to start thinking, outside the box, to accelerate some of the new technologies that we've got, and to start putting them into practice and real-time evaluation. And that's happening in the early detection of cancer space. So I think that's an opportunity that we should embrace as a community, and let's see what we can do.
Well, it's lovely to have that nod of optimism, and I don't feel like we've said anything positive about COVID for the last however many months. So we have to take what little nuggets we can, and if something might come out of it, then thank you very much. And that's a fantastic closing thought for us all to have in these very difficult times, which unfortunately don't look like they're coming to an end anytime soon, do they? Thank you very much. I'd like to say a big thank you to all the questioners, and I apologise to anyone who's dutifully typed up a question and we haven't got to it. I genuinely am looking at a lot on my screen that we haven't had a chance to address, but perhaps the charity will be able to get back to you in one form or another. And a very big thank you to everyone who's been taking part tonight, and to anyone who is so generous as to donate to Cancer Research UK. Hugely important. Thank you to our wonderful panelists for everything that they are doing. Professor Caroline Dive, Professor Rebecca Fitzgerald, and Dr. Serena Nik-Zainal. Thank you very much indeed. And I think I'm right in saying that everybody who's been able to take part tonight will get an email from the charity in the next few days, just outlining what else is coming up and what more we could perhaps all be doing. And I have been asked to mention that for every gift of £100,000 or above, the sum is going to be matched by the Challenge Fund, thanks to one very kind anonymous donor. So if you can manage to donate that remarkable sum of money, it will be matched and it would double the donation, which is just fantastic, thanks to the Challenge Fund. A very, very big thank you to all three of you. A wonderful panel tonight. Thank you very much. And thank you very much, everybody, for taking part and for everything you do. For now, good night.